Hello, so we're back, and this time we have a nice laptop to repair on a beautiful day. So what do we have here? We have a ASUS Vivobook S. We have a i5 CPU. The problem with this one, laptop is dead. Let's check the customer email. The customer is saying ASUS has come in for repair with us, but looks like have a faulty logic board. Shows no life at all. You'll be able to look for us, please. Yeah, we can have a look and try to help this customer. I will say let's plug a charger and see what it's doing. We have USB-C charger. So plug in the meter, plug in the charger, and the meter it is coming on. We have 19 volts, so the PD controller is working. Pressing the power button, nothing happened. Nothing. Okay, let's open the laptop and have a look inside. But that's good. PD controller is working. Most likely the EC chip is working. And looks okay. And the laptop, it's open. Yeah, someone took the motherboard out. The motherboard is looking fine. Plug in the charger again. Let's check some voltages. Let's see what do we have here. Probably the main power is present. But we can check on the capacitor. Here you can see capacitor. The main power is 0.9 volts, and that's not okay. 0.9 is not fine. The battery voltage, here you have nothing, here you have nothing. Not sure which is plus and minus, but we should have the voltage here on the coil. And you have a current resistor here, you can 0 volts. Okay, why the main power rail is not present? Because the PD controller, yeah, negotiating the voltage to 19, so I'm 100% sure it is 19 on the motherboard. Let's follow. Do you think actually the main power is shorted? Has 0.9. So it's not shorted. But let's see. Main power rail is not shorted, yeah? So it's not short here. Without the battery, we should have exactly the same 19 volts. 19 volts. Let's follow the voltage. Wait, this configuration seems familiar. We fixed something like that on the last week, 2 weeks. Anyway, we have two MOSFETs here. I'm pretty sure, I'm 100% sure. So check here, we have the resistor and the capacitor. You remember it was the one with failing MOSFETs, yeah? And yeah, that was the one. Oh lol, on that case we should go straight there. Yeah, remember now. So here, probably we have 9 volts. That's what it was last time. 9 volts, you remember? Let's see. Here we have, actually we have 0, not 9 volts. Yeah. No, it's the same motherboard. It's the same motherboard, and I can bet it's the same issue. Yeah, let me take the board out. Okay, let me take the board out quickly. Yeah, that's the issue. That's the problem, because the PD controller has 19, but the 19 is not passing to the board because the MOSFETs fell down from the board, or they are burned. But let's be cautious. Yeah, let's check the coils a little bit just to be sure I'm not working for nothing. So this one is fine. This one is fine. This one is fine. This one is fine. That's the charging coil. Yeah, everything is fine. Yeah, we can take the battery. We can take the motherboard out. Yeah, let's do it. And the board, it's out. Yeah. I mean, you can see there's some heat. You can see it. And the MOSFETs are not even on the. Yeah, 1 second. One is on the board. One fell off from the board. Check there. One is on the board. One fell off from the board. Where? Wait, this is a screw. Where is the MOSFET? Not sure. It's somewhere. Yeah, now it's part from the nature. Okay, so how we are repairing this kind of fault? Just say it, huh? How we are repairing this? You know what? If I will be dodgy again, I mean, we made a video. Let's say you have this laptop, you want to fix it. You have two options. The PD controller is working. It does not. It's not working. Sorry, it's faulty. But that the fault of the PD controller is actually not providing enough voltage on the gate. When the gate doesn't have enough voltage, the MOSFET it will get hot. Yeah, and on some point it will get burned or yeah. Check that MOSFET. That MOSFET just check here. So the MOSFET was just sitting there like a duck. Yeah, not even solder. If it's good, not sure about that. Not sure about that. So that's the reason why this fault is occurring. Yeah, not enough voltage on the gate. Why not enough voltage on the gate? Because that's the fault with the TPS. And you have two options. One, you short the source with drain. You have two MOSFETs here on the serial mode, channel line MOSFETs. You short this one, and it will work fine. No issue. You can short both. Then both ports, it will work. Both USB ports, it will work. But if you plug on the same time the charger and you plug another device, it is possible bad things can happen. Unlikely, because even if a USB stick is saying like 5 volts, but even if you use more voltage, it will work fine. I think it has a regulator inside. I try with my one. So yeah, just replacing the MOSFET, it will work, yes, but it will work exactly like before. I mean, it will work for a while. The MOSFET, it will get desoldered from the board, it will get burned or whatever. Because not having enough voltage on the gate, the MOSFET is not like a switch, it's a resistor. And a resistor, it will lose current. Now, losing current, the current, it will get changed and heat. And that's what will happen. Now, you have to understand, I'm not Scrooge. If I have parts, I will use parts. If I don't have parts, I'm using what I have, yeah, in order to finish the job. Remember on the last video, not the last video, a few videos ago, a customer sent me a board for spares. So here we have two MOSFETs, yeah, and we have the same PD controller. I believe it's the same. TPS 65994. TPS 65994. So it's exactly the same PD controller and exactly the same MOSFETs. And we can see both MOSFETs are here on the board. Okay, let's quickly fix this motherboard. So it's not like, Sorin is dodgy. I'm just, when I don't have what I need, I'm trying to finish the job and deliver a working laptop. If there are some collateral damage, can be, but, we are doing our best. So I'm gonna use some 180-degree solder wire. Let's redo the MOSFET pins. Yeah, it's looking good. And here is looking good. Okay, now the next step is the PD controller. PD controller, we need some liquid rosin flux, which you can find it on my eBay or United States eBay. You have a link on the description. Yeah, just a little bit of advertise. We need a nozzle like this one. Yeah, that one is good. 480 degrees, 50% air. Let's remove the PD controller. Very simple, straightforward job. Perfect. I pull the chip up, and you see every solder. Check that. Every solder ball is perfect. Nearly every solder. I mean, what is that square thingy? Yeah, I'm not happy with that. With this pin. You see this one, that one, that one. I'm not happy with that one. Okay. 180-degree solder wire. Yeah, let's clean the solder balls. Now we don't have solder balls, and that's fine. We made a video about how we are dealing with no reballing. Yeah, rosin, and we are good. Now let's remove the other PD controller, which is this one. I'm gonna keep the old PD controller. It's still good. I mean, yeah, it's not providing enough voltage, but it's negotiating the voltage. So that chip is still partial good. We never know when we need it. Little bit of rosin flux. MOSFETs, rosin flux. Good. Now removing the PD controller. Perfect. Nearly perfect. Okay, it's not perfect. But the solder balls are perfect, so we can swap directly the chip here. So pin number 1 is still there. That's fine. So the chip has to be here. Good. And the chip just slides when he is placed by himself. Yeah. So that chip is 100% proper soldered. Yeah. Next move is to swap the MOSFETs uh, one by one. Perfect. Pin number 1 is there. Wait, this pin number 1 or this one? Huh? You can't see? Let me zoom a little bit. So which one is pin number 1? Must be this one. Yeah, it cannot be the other one. Yeah, it cannot be. I don't even think it matter because the pins are mirrored. Good. Oh, my MOSFET. Found it. I'm not sure if I found it. Let me see if it's hot. Yeah, it is hot. Yeah, this is the one we lost it. Yeah. I was nearly to have like a heart attack. Bro, I can't believe I lost it again. Found it. What's going on today? Huh? I mean, it is soldered. Just sit on a place. Yeah, okay, the MOSFET, it is soldered on a place. Now grabbing the other MOSFET. This one. Perfect. So this is the other MOSFET. We're gonna solder this here. Come on, just go to your place. More rosin. Let me lower the air by 36%. That one is fine. And this one is fine. Yeah, so both MOSFETs are soldered properly on place. Yeah. So how we can test if indeed the job is well done? Let me cool down the board quickly. And I'm gonna plug the charger here. Meter is coming on. 5 volts. Lol. And here, 5 volts. Remember last time when I did that repair where I short the MOSFETs? And I asked, everyone knows if this PD controller has to be programmed? And people said, no, sorry, no, it doesn't have to be programmed. So my question is, why it's not working? Why? Because I'm pretty sure it's soldered there properly. I mean, no, yeah, I'm not sure what properly means, but looks like it's on one side. It's like slide on one side. Or it's supposed to be like that. It's my fault. Do you think? Do you think I can be wrong about soldering? Really? Yeah, I don't have enough air now. 45%. So 1 second. No, the pins are slide. You can see the pins. Yeah, so it was soldered properly on place. So why is not working? Pushing the chip down? Yeah, let's try it. Yeah, that's fun. Yeah, that's fun. Pushing the chip down, so now we know every solder, it's equal behind of the chip. Yeah. Perfect. Pushing the chip down, it's a good idea when you are not sure if every ball is equal behind of a chip. You push the chip down, the solder is coming out, and you cannot have bridges. So if you have flux, you cannot have bridges. So you know, then the chip it is soldered properly. We made a video using like a big easy chip, like this size easy chip, and solder without rebolting. Good. Let's see now. Plug in the charger. 5 volts. Hmm. You know what? I'm 100% sure the chip it is soldered properly, and I believe the chip is good. I think I have that chip on my box. One second, let me check. Let me see if I have that chip here. No, I can't see it. I seen it somewhere, the chip, but not sure where. This one? What chip is this brand new one? Huh? So that brand new chip, I mean, it's looking the same. We have to clean it. See what chip it is. It's looking the same, you know, has same color. Must be the same duck. TPS 65994. Yeah, that's our duck. So we have another duck here, another chip. Okay, so I'm gonna remove this PD controller. Perfect, good. And I'm gonna solder this one, this brand new chip. Solder coming out, that's fine, that's okay. That's okay. Because now the solder balls are equal. Yeah, so behind of the chip, now every solder ball it's equal. So it will be working or not, huh? Why the job got so complicated when it was like 1 minute, you know, soldering two wires? Plug in the charger. 5 volts. It's not working. This chip has to be programmed. This is the second chip I'm soldering. And I'm pretty sure that it's soldered properly there. No, it's not working because it has to be programmed. Look, I'm gonna try something more, yeah? Just to be sure every pin is soldered behind of this chip. Pushing the chip down. Yeah, so we push the chip down again. Good. So now we know it is soldered properly on place. I can assure you that. It looks dodgy, but it is soldered properly. Plug in the charger. Nah, 5 volts. No, no, no. We swapped two chips. Okay, let me find another one. I think I have on a board another one. Let me check. 1 second. Okay, you know what? I don't have another chip. No. Let's solder back the original chip. What do you think? Huh? Let's solder back the original one. Let's see, we are getting 19 volts on the charger. Good. So that's out. And we have to solder this one. No, this was not the original one. No, not this one. Okay, so we have the original TPS chip. We're gonna solder this. This position. Good. Let's use some flux. And the chip slide on his place. Good. Let's see. Curious, I'm curious. Charger. So plug in the charger. And we have light. We have 19 volts. We have 1 amp. The laptop is working. You can see. So the point I'm trying to make, we replace two chips. Maybe the one from the board, possible to be that, but the one from my box, 100% is good, because that's the reason why I keep that on my box. So what happened now? Now, we're gonna check with the thermal camera to see what MOSFETs are doing. I mean, okay, the board is taking like 1 amp, it's coming on. Yeah, we do have heatsink. Yeah, that's fine. If we have heatsink, it's fine. But let's see what our MOSFETs are doing. It's taking a 1.3 amps. It's working fine because we soldered the MOSFETs. So, with the thermal camera, actually it's looking good. I mean, the MOSFETs are cold. You can see them? You can see the MOSFETs in the chip? I mean, it's more hot. The chip, the EC chip. The EC chip is hotter compared with my MOSFETs. Can I check if the voltage is right on the gate? No, we can't check that. No, you can't check. No. You have no place to check. So the tracks from the IC are going straight to the under the MOSFET. So both MOSFETs are working. The PD controller is working again. We soldered the chip again. Yeah. What I think this PD controller has to be programmed. That's what I think. I mean, we replaced two chips, two. But anyway, you know, you can always let a comment, leave a comment, and you know, maybe I'm wrong. You know what I mean? Let me try something. Yeah, it is something what we can check. Yeah, let's check. How we can figure it out if everything is fine. And it's very easy, but I didn't think about that. We can check the voltage. Yeah, if it's no voltage drop, most likely it will work. So the voltage, 1 second. So this is the output 9.9, and the input is 19.9. Yeah, here is 0. 19.9. Maybe the chip just need a reflow, but looks fine. Doesn't look like have any voltage drop. Anyway, not sure what should I say about this repair, but the board is fixed. If you want to make sure, even if the chip is dead, you want to make sure the MOSFET it will not fall down from the board. You can use just a little thermal pad here, and the MOSFET it will not get melted, it will not fall from the board, even if the chip is burned. I can assure you that. Remember a while ago, probably like half of a year, more than half of a year, we done same job, but it was with normal MOSFETs. So I used like a thermal pad there, and without replacing the chip, and the job never came back. Yeah. Okay, let me put the motherboard back quickly. I know how he's looking for some people which they are hobbyists. Yeah. If you try to rebuild this chip, let's say I want to do it properly, it will take you a long time. So we swap the chips like what, like 3 times? I mean 3 times, let's say like 10-15 minutes for a rebuild. That's a lot of time. So it's better to learn. I mean, it's nothing to learn, it's just practicing. Soldered ICs without rebuilding. That's a lot better. It will save you a lot of time. It is any downside like soldering the chips like without rebuilding? No. Not for us, for machines, yeah. So they need like error margin when they are soldering IC also on the board. So that's the reason why there are solder balls. But for us, it's fine. It's okay. Now going to the big chips, like CPUs, like chipsets, GPUs, then you have the margin of errors is very small because you have like board bending from the heat, and yeah, you really need like solder balls. But otherwise, I see like this side is fine. Yeah, up to this side you have no issue, no problems. But my personal opinion is the fix and the repair which I did at like probably like 1 week, 2 weeks ago, shorting the MOSFETs with a wire, which is like 1 minute job, is the best way to repair this fault. I read the comments, but you have to understand 99.99999 time from the time a user is using the charging cable to charge the laptop, yeah, not actually to transfer the data. So that kind of repair, actually repairing the both USB-C ports, for me looks more than safe. Okay, I use few screws. Let's test to see indeed if it's working fine. Yeah. So I'm gonna plug the charger. We plug the battery. Plug in the charger, and the meter it is coming on. Again, we have two ICs here. We tried with both and didn't work. We have 19 volts and 4.5 amps. It's taking a lot of current charging this battery. Yeah. Pressing the power. Oh, the laptop is on, doing updates. Huh? Strange. The laptop died during the update. Fan is spinning. We have the charging light, blue light. Yeah. Yeah, the heatsink is warm. Here everything is fine. Now one more time. This job for me is a no-go. I mean, this job has chance to come back. The job I made it probably like 1 week ago and 2 weeks ago, she's shorting the MOSFETs. This job it will never come back. Yeah, so 100% for me that's the way to go, and it's working fine. Here we have a picture on the screen. Okay, I mean, yeah, everyone has an opinion. My opinion is the more complicated a thing, yeah, a design, a schematic, whatever, the chance to get broken is rising. So keeping the thing simple, like before, you remember charging port, round pin, Asus, Toshiba, Acer, whatever, no issues, no problems, yeah. But now we have like USB-C, we have MOSFETs, we have PD controllers. You know, we complicate this design a lot for nearly no reason. I mean, what the manufacturer it will cost to use like a charging port, 19 volts, two MOSFETs, main power rail, and feed the charge. Like even here is a lot of space. You can fit a charging port with a round pin, no PD controller, no things. You know, like round pin. I mean, how hard that can be. Yeah, and you leave the USB-C for data. And if you leave the USB-C only for data, they will never get broken. Never ever. Yeah, never ever it will get broken. You leave the USB-C for data and use the round pin charging port to charge the laptop. But hey, it's, progress. Yeah, it's working fine. Working fine, charging fine. We have the charging sign there. Okay. So I'm gonna stop now. I will say thank you for watching. Hopefully, one more time you figured you learn how to fix this fault. Um, Again, I'm confused. I'm ending this video confused. Not sure if that PD controller has to be programmed or not. I believe has to be programmed because we replaced two chips, two ICs, and they are not working. And when I'm saying not working, you see in the voltage we had like 5 volts and like 300 milliamps. So the chip, it was soldered, but it was not negotiating the voltage. It was not speaking with my AC chip. That's the reason why it was not negotiating the voltage. So I suppose I will see you on the next one, yeah? Bye. Hey, if you find my content being helpful, don't forget you can support this channel by pressing the join button, and you can get instantly access to our members only cool collection and Discord private channels for support with your repairs. Also, you can have a look on our United Kingdom eBay, where you can find some cool and unique products, United States eBay store, or our Patreon page. Thank you.